Hello everyone, welcome to this video tutorial on logical operators in Matlab. These are the learning outcomes of this video. After this video lecture, you will be able to write expressions using logical operators to combine multiple conditions. You will be also using logical operators to create more complex decision making structures, and will understand the order of precedence for logical operators and how to control it using parentheses. So there are three types of logical operators available in Matlab. These are AND, OR and NOT. So I'll choose laser pointer. So the first one is AND, and it is used in Matlab like this: A and B. So the AND symbol is used to represent AND operator. It operates on two operands like this, A and B. If both the operands are true, this operator will give result as a true, that is true 1, otherwise the false, it is false. Now there is second operator OR. This is represented by this vertical line. Example A or B. It also operates on two operands. If one or both are true, the result is true, otherwise false. And this is the NOT operator. This is the symbol for the NOT operator. It operates on one operand and it gives opposite of the operand. True if the operand is false, or false if the operand is true. So it reverses the conditions. Okay, so let's see what are the types of operands we can use in case of logical operators. So there are two types of operands we can use. The first one is number as operands, and the second one is conditional statements using relational operators as operands. Okay, so how we can use the numbers as operands? So if there is any non-zero number, it is considered as a true condition, and if there is zero, it is considered as a false condition. Now we will see in Matlab how to use this number operands. So we will be using number as operands in following examples. Just make it full screen. Okay, so it's better to visualize. Now in this video I'm using this live editor format. Can go new and live script. You can choose a live script, so you can create a file like this, and here we will have a extension of the file mlx. So in this you can combine the text, images as well as codes. Okay, so the first thing is we have to use numbers as operand. Let's say we are considering 5 is a number. Now 5 itself is considered as a condition true, and 7, so both are the number, those are non-zero. So 5 and 7 is nothing but the true condition, and it should give you a result 1. You can see here logical 1. Now if we will replace this thing, enter, and 5 and 0. Now in this case one of the condition is 0, or one of the number is 0, and if number is 0, it is considered as a false condition and it will give you a result 0. So we will run this again. Now you can see we are getting answer as a 0 or a logical 0. Now this is how you can use numbers as operands. We will go with OR operator as well. Now I will say 5 or 0, and now in this case we will see what are the results. So first case, if we have used AND condition, it is giving 0. For OR condition, it is giving 1. So like this, in AND condition, if any, what is the AND condition? We'll go to the slides. We need both the operands are true, then only it will give a true results. So if both the numbers are non-zero, then only it will give true results or 1 results, logical 1. In OR condition, if any one is non-zero number, it will give 1, logical 1 as output. If both are false, then it will give 0 as output or logical 0 as output. Okay, so you can I will see how does this NOT operator also works. So this is the symbol for a NOT. You can obtain it using shift and very first button in the row of your keyboard. So that's the NOT symbol, and 5. So the third answer should be 0. We'll run it and you can see this is giving 0. Now we can assign variables to it. Let's say this is variable 1 is equal to, this is variable 2 is equal to, and this is variable 3 is equal to. Okay, now we will run this thing. Now variable 1 is logical 1, variable 2 is logical 0, and variable 3 is logical 0. Okay, now we'll create variable 4 is equal to, we'll say not 0, so it will give a true result, that is 1. Okay, so this is how you can use numbers as operands or scalars as operands on a logical operators. Okay, now if you want to use this as a operators, these operators, logical operators in mathematical expressions, you can also use that thing. So let's say we have one variable var5 is equal to, and we'll use these conditions in a mathematical expression like this. Okay, control V plus, I'll say 5 or 0, and then I'll say plus 3 star 2 star 3, then I'll say minus not 5. Okay, so if we will calculate this thing, we'll get some answer 8. So how we are getting this 8? This is nothing but 1, and this is also a 1. So 1 plus 1 will become 2, and this 2 plus 3 will become 6. So 2 plus 6 will become 8, and minus 0. So this not 5 will become 0. So this is how you can use the logical operators in math expressions as well. So whenever you will use this logical operators in math expressions, this result of this expression, this parenthesis or this bracket, will be termed as a positive 1 or a number 1, and this is not a logical anymore. Now we can use the logical operators on vectors as well. Okay, so we will create two vectors is equal to x is equal to 2 3 8 2 3 8 4 9. Okay, then we will have another vector is equal to y. We'll consider this as a 1, then 3 7 4 and 10. Okay, this is another vector. Now we have to use the logical operators on these vectors. Now what we will do, we'll do this thing, variable 6 is equal to x and y. Now what is the output? What do you expect? What will be the output? Okay, let's run it and then we will see. Okay, so this is giving a single digit output for each and every element in x and y. How it is doing? it is checking element by element. 2 and 1, it is 2 and 1, it will give 1. Okay, 3 and 3, it will give 1. 8 and 7, it will give 1. 4 and 4, it will give 1. 9 and 10, it will give 1. Okay, this is like we are getting the variable 6. Now we will create another one vector. Let's say x, y, z. Z is 0, 0, 4, 8, 9, 10. Okay, so this is how we have vector z. Now we'll create a variable 7 and we'll say x and z. Now that's z, and we'll run it. Now you can see there's some difference between variable 7 and variable 6 and 7. Now we got this first element as a 0 because we have used x and z. If we compare 2 and 0, 2 is true condition and 0 is a false condition. So true and false will become false, because for AND operator, if both the conditions are true, it will get 0, you will get 0, otherwise you will get 1. Okay, sorry, if both the conditions are true, you will get 1, otherwise 0. So that's why we are getting a 0 as first element, otherwise we are getting 1 1 1 1 for last 4 digits. Okay, or last 4 elements. Now we'll apply this same thing. Variable 8 is equal to x or y. So I want small letters and we'll run this again. You can see here, now any one condition is true, then for OR operator we'll get 1 as output, logical 1 as output. Now we'll do this thing for the same and we'll check. So here also, sorry, I have not replaced this with OR, and so here also we are getting all the ones for all the elements. So this is how you can apply logical operators on vectors. Now we'll see how the NOT will work, where 10 is equal to NOT x, and we'll get all the values. I want x, and we'll get all the values 0 because all the elements are non-zero here for x. So we are converting the results to the, or we are getting opposite results to the all the elements, as these are all non-zero numbers, these all conditions are true, and if we apply a NOT to it, we'll get all the elements of variable 10 will be 0 0 0 0 0. So that's how you can apply the logical operators on numbers as operands. Okay, so if you want, you can also check with this z. Variable 11 will become 1 0 0 0 like this if we apply on z. So 1 0 0 0. So this is how you can apply the logical operators on vectors of the numbers. Then you can use them in logical mathematical expressions, and you can apply them to logical numbers on the scalars as well. Okay, so next thing, we have to use conditional statements as operands. So we'll go to the slides. We'll see the slides first. So these conditions are the output of the relational operators applied as conditions. Like if we compare -5, or if we -5 is less than 2, so it will give it will act as one condition, and its answer is yes, it's true. so it will act as one condition, and we can use AND operator between this condition and another condition to use as a conditional statement. So these are the relational operators we have already seen in previous videos. Now we can see how does this relational operator works first, then we can go to the conditional statements, and then we can use logical operators between the conditions. Okay, so we'll start with the less than symbol. So less than symbol, okay, -5 is less than 2, so what will be the answer? It's 1. Okay, so its answer is 1. Okay, then this is the first condition, let's say. Okay, we'll apply this condition 1 is equal to, and we apply condition 2 is equal to. Now what? Okay, 4 is greater than 5. Yes, it is also true. No, 4 is not greater than 5. I want, yeah, it will work. We have two conditions. We'll create a third condition as well, condition 3, that is 6 is greater than equal to 6. Now this is also a true condition. Yeah, so now we will use this condition 1, condition 2 and condition 3 to convert these condition statements as operands for logical operators. Okay, so how does it work? Okay, so condition 1 and condition 3, and we will run it. So we are getting answer as a 1 because condition 1 is true and condition 3 is true. Okay, so we are getting the answer 1. If we do this with the condition 1 and condition 2, we are going to get answer as 0. Yes, that's correct. Now we'll replace this thing with OR conditions or logical operators. Now, so both in both the cases here, we must get 1 as an answer. Logical 1, logical 1. Yeah, that's correct. So this is how conditional statements as operands can use for logical operators. Now, how does the order of precedence work? So if we are using this logical operators, relational operators in mathematical expression, how does the order of precedence work? So first of all, it will solve the parenthesis, then exponentiation, logical NOT will be solved after exponentiation and before multiplication and division, then addition, subtraction, relational operators are there, then this is, I think so, NOT operator, then so NOT is covered here. So this is why, what is this? Greater than, equal than, less than, equal to, and not equal to. This is not equal to. Then logical and logical OR. So we'll correct this not equal to symbol. So go to the slides. So this is not equal to. Now we want ink pen. Okay, so this is nothing but not equal to eraser and pen. So this is not equal to symbol. That's a mistake here. This is not correct. Instead of this is not equal to symbol. So this is the order of precedence. Then at last you will solve the logical OR. So how to use all this thing in a expression, mathematical expression? So we'll add some code lines here. Okay, now maths expression is equal to what we will do. We'll copy this thing. We'll have matrix and parenthesis, sorry, and this thing plus. Now what we have to do, we have to do not 5, okay, plus 6 is not equal to 10, okay, then plus not equal to y, we have x value or okay 2 less than 7, and there will be a not 2 less than 7. So this is the mathematical expression and we can run this. So we are getting logical 1 as a output. Okay, now if we will do this thing and then we'll solve, then we are getting 2 as output. Oh, okay, so that was some mistake from my side. Now we can calculate this, how we are getting this 2. Now what was this condition? This is true and true. 4 is greater than 5. 4 is this 1 and 0. So if one condition is false, we are getting 0 here. So I'll type it here. E calculated is equal to the first bracket, we are getting false as 0, okay, plus this will be 0, we are getting 0 here. Then 6 is not equal to 10, that's true, plus what is this, 2 is less than 7, yes, that's correct, but we have not operator here, again we are getting 0, then plus. And now what is the change here? Not 2 is less than 7. What is this? What is the answer of not 2? Not 2 means 2 is non-zero number, so already its condition is true. If we have applied a not, it will become 0. Now 0 is less than 7. 0 is less than 7. I will write it here. So 0 is less than 7. Yes, this condition is true, so we'll get 1, and if we get run this thing, we get 2. So this is how it is calculating this expression. So, and this is how you can use the order of precedence while considering the logical operators and relational operators as well. Then we'll use this logical operators on vectors. Yeah, we already used this thing, we need not to go. Yeah, now we have some built-in functions. Go to this thing. Yeah, so there are some built-in logical functions we generally use in programming. These are very important logical functions because these are directly applicable to matrices as well as scalars, as well as what I will say, vectors. So, and while programming, I have several times used this any, find, these logical functions while programming, so this is very important. Okay, so we'll start with XOR. So that is exclusive OR. It returns true if one operand is true and other is false. Okay, so if any one operand is true and other is false, so we'll get the result as 1. Okay, so in OR operators, if both are true, then also we'll get 1, but here only one operand is true, then only we'll get 1, otherwise it is false. Okay, so this is the example XOR 07. So here this is true condition, this is false condition, so we are getting 1. Now this is true condition, this is true condition, both are true condition, then also we are getting this 0. So we'll try this in Matlab. Okay, so instead of this thing I'll write here what is this, B in functions, built-in logical functions. Okay, and this is heading. I'll go to this and I'll type this as a heading. So the first thing is the XOR, logical function. So XOR, how to use this function, you have to use XOR and number 7, 0. So if we'll run this thing, we are getting this answer as logical 0. So we use the variable name, or what we'll do, CLC and run. It's not working here, I think so. Okay, no issues. We'll write the variable name exclusive OR is equal to, okay, so exclusive OR we are getting a logical one because one operand is 0, okay, and one operand is true, that is non-zero. Now we will use control C underscore 1 and I'll replace this with 5 and we'll run this. You can see here, if both the conditions are true, it is giving 0. Now if both the conditions are false, it also give 0. Okay, then this is true, this is false. Again we will try with one more true condition with -5. -5 is also a non-zero number, so again this will also give a 0 value because here all the conditions are true, that's why it is giving us value 0. If only one condition is true, then only we are going to get 1 as output. Okay, so this is a XOR logical function for you. Then we'll go to the next, all. So this is also very important logical function. It returns 1 if all the elements in vector A are non-zero, or it will return false if one or more elements are 0. Okay, so we'll test it. Okay, I want text all logical function. Okay, now we have to create a variable vectors. Okay, so we will use those vectors only. Okay, yeah, that's it. So we will apply all to x, then I want it a lowercase, then control C y, then control C control V Z. Okay, so you can see here, if all the elements in the vector are non-zero, we are getting 1 for x, for y as well. But if there is any one element that is non-zero, that is 0, we are going to get 0 as an answer. Okay, so this is function all. It checks if all the elements are non-zero or not. Checks all the elements are non-zero or not. Checks CHECK all the elements are non-zero or not. If all the elements are non-zero, you are going to get 1 as an answer, otherwise 0. Then we'll move to the next function, that is any of A. So it will give 1 if any element in the vector is non-zero, otherwise 0. Okay, otherwise 0. So we'll move to the thing and we'll test it with the text. All logical function, then we have any. So we'll just copy, or I'll just copy this and place with any. Now run this thing. You can see here any x, this is the output. Yes, any x, it's true. Any y, it's true. Any z, it's true, because it will check any one element is 0 or non-zero or not. Any one element. Now if you want false answer, we have to use w is equal to 0 0 0 0 0. Now if we check any w, at the end we should get answer as 0. Yes, that's logical 0. So for w, all the elements are 0, so any will work or give an answer true only if there is one element is 0. So if we replace this with 1, we are going to get 1 as a answer. So this is what we get when we use any logical function. Then we have find, that is last of built-in logical operator. So want this thing, find function, find a. I should write this like this. Okay, so we'll use this thing, find a. Now what does the find a do? Okay, we'll read it here. If a is a vector, it returns the indices of all non-zero elements. So if you apply find to the a, it will give all the indices of the non-zero elements. Okay, we'll test it for z and z only. Find z. Okay, so we have this 2 3 4 and 5, 2 3 4 and 5. Okay, so these are the non-zero elements. Okay, now we will try with the find w, and it should give empty vector. Yes, that's correct. So we are getting empty vector. Now there is one more addition to the find. If you want elements which are greater than 4 from this z, so we can use find elements of z, those are greater than 4. So if we run this thing, we will get the indices of the elements, those are greater than 4. So this is how you can use the find command. Okay, so that's it for the logical operators. This is very important video. Before you go to the looping or conditional statements, you must know how to use the logical operators to prepare the conditions or use the conditions effectively. So thank you for watching this video. Kindly like, share and subscribe to this video and channel. Thank you.